On September 5, 1977, a rocket left Cape Canaveral carrying what would become the farthest traveling object humans have ever built. It almost didn't get there. The first stage shut down early and left 540 kilograms of fuel unburned. The upper stage burned longer to make up the difference, and when it finally cut off, it had 3.4 seconds of propellant left. 3.4 seconds. That was the safest thing that ever happened to Voyager 1. Voyager 1 exists because of an accident of orbital mechanics. Once every 176 years, the outer planets line up so that a single spacecraft can slingshot from one to the next, stealing a little energy at every stop. That alignment was coming in the late 1970s. If NASA missed it, nobody alive would get another chance. Congress wouldn't fund the full tour, so the mission was proposed as something smaller. 2 probes, Jupiter and Saturn, nothing more. The engineers built them to last far longer than that anyway. The machine they launched carries roughly 70 kilobytes of memory in total. The phone you are holding has about 1 million times more. Everything Voyager would ever learn to do after 1977 had to be taught to it across empty space, one command at a time. It reached Jupiter in March 1979. For the first time, the largest planet in the solar system stopped being a smudge in a telescope and became a place. Storm bands wider than Earth. A red spot that had been spinning for centuries. Moons with actual surfaces. And then it found something nobody had asked it to look for. For days after closest approach, a navigation engineer named Linda Morbido was processing an image of the moon Io that had been taken purely to check where the spacecraft was. Off the edge of the moon, there was a faint crescent-shaped cloud, 270 kilometers tall. She worked through every explanation she could think of. A blurred moon sitting behind it, a flaw in the camera, an artifact of her own image processing. None of them fit. What she was looking at was an erupting volcano, the first active volcanism ever seen anywhere but Earth. Io wasn't a dead rock. It is the most volcanically active body in the solar system, and it had been that way the entire time we'd been staring at it. A routine navigation photo found it by accident. Then came the decision that ended Voyager 1's career as a planetary explorer. At Saturn, mission planners had 2 options. They could keep the probe in the plane of the planets and let it continue outward toward Uranus and Neptune. Or they could aim it at Titan. Titan had an atmosphere, a real one, thick and nitrogen-rich, the only moon in the solar system with weather. Nobody knew what was underneath it. They chose Titan. In November 1980, Voyager 1 flew close, pointed its cameras, and got back a featureless orange ball. Titan's haze was completely opaque at every wavelength Voyager could see. It would be another 25 years before the Huygens probe finally landed and found the rivers and lakes below, and the flyby geometry through Voyager 1 beneath Saturn's south pole and up out of the plane of the solar system permanently. There were no more planets on its path. There never would be again. It traded Uranus and Neptune for an orange fogbank and aimed itself at nothing at all forever. Bolted to the side of the spacecraft is a 12-inch copper disc plated with nickel and then gold. Carl Sagan chaired the committee that chose what went on it, and the selection took them almost a year. They picked 116 images, greetings in 55 languages, thunder, surf, a kiss, a mother and child, music for Bach to Chuck Berry to a Navajo night chant, and one thing that isn't a recording of the world all. And Drew Yin, the record's creative director, went into a lab and had an hour of her own brainwaves recorded, then compressed into about a minute of sound on the disc. By her own account, she and Sagan had agreed to marry only days before. So while the electrodes ran, she thought about the history of Earth, about what our civilization is up against, and about what it feels like to fall in love. That is on the record. It is leaving the solar system at 17 kilometers per second. Sagan had wanted one more thing since 1980. Turn the cameras around and photograph Earth from the outside. The engineers pushed back for years, and they were right too, pointing the optics that close to the sun risked blinding the spacecraft permanently. By 1990, it no longer mattered because there was nothing left ahead worth photographing. On February 14th, 6 billion kilometers from home, Voyager 1 turned and took the picture. Earth came back as a speck of light caught in a band of scattered sunlight, occupying about a tenth of a single pixel. Every person who has ever lived in a tenth of a pixel. Then NASA powered the cameras down for good. Voyager 1 has not taken a photograph in 36 years, and it never will again. It has been flying blind ever since, which made the next problem strange. How do you prove a blind spacecraft has left the solar system? There's no line out there, no sign, nothing to see. The boundary is made of plasma, the place where the thin wind blowing off the sun finally loses to the gas between stars. Voyager's plasma detector had failed back in 1980, so it couldn't simply measure it. What it still had was an antenna that could hear plasma vibrate. In March 2012, the sun let out an eruption that rolled outward for over a year, and when it finally washed over the spacecraft, the gas around it rang like a struck bell. The pitch of that ringing gave them the density. It was 80 times thicker than solar wind. That is not our sun's atmosphere anymore. Working backwards from the data, the team placed the actual crossing on August 25, 2012. They could only confirm it 13 months after it happened. Voyager 1 left the solar system, and for over a year, nobody on Earth knew. On November 14, 2023, the data coming back stopped making sense. Not silence. A repeating, meaningless pattern, the same string over and over. A single chip in the flight data system had failed, and about 3% of its memory was corrupted beyond repair. The code stored there was the code the spacecraft needed in order to speak. The engineers who fixed it were working from 1970s paper documentation written by people who had long since retired or died. They were debugging a 46-year-old computer with a round trip of nearly 2 days for every command they sent. They found the damaged section, cut the code into pieces, and tucked each piece into whatever gaps in memory would still hold it. On April 20th, 2024, Voyager 1 started making sense again. The following year, they went further and revived a set of roll thrusters that had been considered dead since 2004. Every fix buys time. None of them buys power. The plutonium aboard Voyager 1 has been decaying since before it launched, and the spacecraft loses about 4 watts of power every year. Instruments have been switched off one at a time to ration what is left. 2 are still awake: the magnetometer and the antenna that heard the plasma ring. Sometime in the next several years, there will not be enough power for even one, and the signal will simply stop. It will keep going anyway. This November, it becomes the first object humans have built to sit 1 full light day from home. Send it a message, and the reply takes 2 days. In about 40,000 years, it drifts within 1.5 light years of a dim red star called Gliese 445, which will never know it passed. The record will still be bolted to the side, still carrying an hour of someone's brainwaves compressed into a minute, still playing nothing to no one for a very long time. If you're building the next one, what would you put on it?